All right, we've already gone through and done graphs of the sine function. We took a look at how these graphs came off the graph of the unit circle and where the values came from. So we looked at sine already, so let's go ahead and take a look at a cosine function. And we'll start with the basic one, the parent function. So we'll just go through and make our graph set up. And then, like I said in the other section, what you want to do is draw your curve first and then go through and mark the x and the y axis. So if I just go with the regular cosine function, first off, let's try to remember that the maximum value that either the sine or the cosine can be is 1. The minimum value it can be is a negative 1. So now cosine, which is the x distance, if I start out at 0 radians, then the point is exactly 1 away from the center, okay? And that's the x value. So I will go through and I will start at 1. So the cosine always starts at either the highest point or the lowest point. And since the graph of the cosine is the exact same looking graph as the sine, we just start at the high point, come through, rotate our way down, hit the low point, cross again, hit our max value, and that's one full rotation around the unit circle. I'm going to go through and keep drawing this out though, and give it a little arrow at the end because it continues. I'm going to go this way and continue in that manner. So now I want to go through and I want to label. So the easiest way, because it's difficult on graph paper to go through and do this, the easiest way is to draw out the x and y coordinate plane. Okay, that's the easiest thing to do first, and then draw your graph on there. Like I said in the last video, after a while you'll start to get them where they're not, like the front part of the curve is not a different size than the back half of the curve. It's just a matter of time and a matter of practice. So we start here at 0 on the x-axis, and we go across the x-axis. We have crossing here, minimum, crossing, maximum, crossing again, and back here we cross again. We have to label every point where we cross the x-axis or midline, and then we have to mark every maximum and every minimum on the axis. So now on the y, again, since this is just the plain old cosine, here's where 1 is, and then right about here is where negative 1 is. So one full rotation all the way through will be 2 pi. So right here, this is my period. So again, the amplitude is 1. The period is 2 pi. All right. We have no phase shift back and forth. We have no vertical stretch because that would have been shown with the amplitude. It's starting at the high point. If this started at its low point, then this would have been a negative because it would be a reflection. And we don't have any change this way because our period is 2 pi. So now let's go through and we'll, there's 2 pi. Halfway back, well, that's pi over just pi. Half of that is pi over 2. 3 pi over 2. Then we need another pi over 2, so that's going to be 5 pi over 2. Then we're negative, so this would be negative pi over 2. And there is your basic graph of the cosine. Again, remembering that we start at either its high or its low point. Then we'll cross the midline, and we have to mark each maximum, minimum, and where it crosses the midline. All right, so of course the next one's going to be a little bit more complicated. Actually, it's a lot more complicated than the one that we had just done. So we're going to go through, we'll draw our graph out. Okay. Oof. That goes way uphill. So you know what? We're going to erase that and try that part again. And again, bear with me because I'm using a tablet as opposed to a nice piece of paper where I could just go through and use a ruler. All right, so it's all by eye. All right, that's better. Not great, but it's better. All right, so we'll continue this out this way. Okay. So now we're going to go through, we're going to look at the very beginning here and start to figure out the different components, just like we did with all of the other functions. So I've got a negative in front, so that negative in front means we reflect about the x-axis. Then we've got that 3. So that 3 then means the amplitude is equal to 3. Then we have right here, all right, so remember, I'm going to write it down here, y is equal to a, and then in parentheses, bx minus c. Yeah, okay, it helps if you actually put the cosine in there. So let's try that again. Erase here. Okay, my bad. All right, back to the pen. So again, a cosine, yeah, it helps when you actually put the trig function in, bx minus c plus d. The part here now, we do not have anything here. All right, it's just this. All right, so when dealing with phase shift, we didn't talk about this in the other video, but when talking about phase shift, the phase shift is equal to c divided by b. So that means in this case, c is pi over 2, b is nothing. So then my phase shift is just pi over 2. And remember that it's an x minus, so that means that this goes negative. So that means this thing, this graph, wherever it would normally start, is now going to start back to the left pi over 2. And then we have to look at this last part here, the plus 1. Plus 1 means it's a vertical shift, so it takes the graph off, moves it up 1, and then drops it all back down again. So now this also means that we move up 1 unit. All right, so we had to do all of that before we even start graphing. So we know it's a cosine. Cosine either starts at its max or its minimum. It's got a negative in front, which means it's going to start at its minimum. We have the plus 1 at the end, which means that's where my midline is going to be. So the first thing I got to do is draw my midline. So we're going to go through and we're going to draw our midline. And again, it has to be dashed because it is not part of the graph. Okay, so there's my midline, and we'll label it as y equals 1. Then it says, all right, so it has an amplitude of 3. So there's 1, 2, 3. That means, so 1, 2, 3, that's going to be where the minimum would be. And then I need to go 3 up. 1, 2, 3 up. All right, so let's label these values. So there's a 2 there. And then 1, 2, 3, so that added to the 1, that gives me a 4. Don't forget this is negative. Cosine would normally have started down here and then moved its way to the midline, come up, turned, come back down, down again. But the problem is we've got this shift. So that means that we have to start back here. So I'm actually going to have to say, all right, well, there is, unfortunately, we have to put our marks in and then hit our marks with our graph. So this then is negative pi over 2. So the graph actually starts, and I'm going to change colors. The graph actually starts here. We do not have a compression this way, which is good because to have all of these different parts together would make this a little bit more difficult. So what happens is we're going to come through, and here is where we will cross the midline. So we're going to cross the midline, then we're going to go up and hit a max. Then we're going to cross the midline. Then we'll hit our minimum. Then we will cross the midline. And I'm just going to keep going, even though we don't need to go that far. But now you got to make it match the best that you can. And here's where, if I was using just a piece of paper, you can kind of see I'm just sketching it out, not with a full-on straight line, but just with a bunch of smaller lines to go through and try to get it to reach. Okay. So now the key is just getting these values and knowing where you're at. So let me change back to the color again that we used for everything else. So here's 0. Again, it's maximum. That's going to be at a pi over 2. Then it crosses again, so that's at pi. Here's the minimum, so that's 3 pi divided by 2. Here's where it crosses again, so that'd be 2 pi maximum 5 pi over 2, and then I go back to crossing again, so here's 3 pi. All right, so let's make sure that everything comes out the way that we're expecting. So it's always great to go through again after. So we've got the negative. That negative sign means that we're going to start at the bottom as opposed to the top, because cosine either starts at top or bottom. Sine starts at the midline, okay? So we then had the 3, which is the amplitude. We did have a phase shift. We had to move it back to the left, pi over 2. So that's why we started here. All right, so we started back here, then came up and did our graph. All right, now if I were to just ignore this half and ignore the equation here, you notice that this could actually be rewritten as a sine function, and that is another story for another day. But right now, this is the equation that we have, and this is what the graph would look like. All right, so now let's take a look at another example. This one is coming straight out of what if I have the equation already done, and then I'm going to draw it out. Try that again. What if I have it already drawn out, and then I want to come up with the equation? All right, so the first thing we got to do is we got to pull out information from here. So let's see, if I look at it along the x-axis and the y-axis here, so when x is 0, I'm at the high point. So this is most likely a cosine. And again, it can be written in either, but it's easier to write as a cosine because then we don't have any left-right shift. So now it hits there, comes down, hits its minimum, comes back up, and then goes through. So it finishes an entire cycle by the time I get to 2 pi. So that means then the period has not changed, unlike the one that we did for the sine graph when we had to come up with the equation. So that's nice. So I don't have to change any of that. We do have a stretch because notice here I'm at 2 and down here I'm at -6. So then I've got to find the middle of that. So then, what did I say? I'm at 2, I'm at 6. So then I have to be 4 away. So that means my amplitude is 4. So now I got to find where my midline is, and my midline would be 4 away from the max and 4 away from the min, which is at -2. So let's go through and we'll draw our midline, just because it makes our life a little easier. So we get the midline. And plus, we will ask you, based on the information that's here, what's the midline? And make sure when we ask you what the midline is, you give me an equation. Okay, midline is not just going to be a point. Just like an asymptote line was not just a point. It was a line, vertical or horizontal. All right, this is, again, dashed because it is not part of the graph. It is just used to help us kind of guide us. All right, so we know it's a cosine. It starts at its high point, so that means it's going to be a positive cosine. It has an amplitude of 4, so that means it's going to be stretched this way. So then my graph starts out as y equals, it's positive because it starts at the high point, amplitude is 4. Then cosine. It's not being changed this way at all. It's not being picked up in phase shift either direction, so I can just say nice cosine x. Then we got to deal with the midline. Well, the midline is down 2, so that means the whole graph was picked up and dropped down 2. So then -2. And there is our graph equation for that graph. All right, so hopefully these examples were helpful and to get you to a better understanding of what we are looking for when graphing. It's a lot of moving parts, but the nice thing is that these moving parts are the parts that you've seen in all the other functions that we've been working on. It's just how do we get these points compared to how we got the points for the other ones. All right, but everything is still the same. The up, down, left, right transformations, all of that's the same. All right, so again, hope you have a great rest of your day and hope this was helpful.